a nice first presentation. My name is Patrick Burgess. I'm a lecturer at the Aries University of Applied Sciences and also have recently started my journey towards a PhD. So I'm currently a PhD candidate. Together with my supervisors, Fanladi Sanmola from the University of Hertfordshire, and with my local supervision, Sigrid Wertheim Hack from the Wageningen University and Research Center, we've conducted, well, this is a part of a larger research that we're working on, and this specific paper was titled Blockchain-Enabled Quality Management in Short Food Supply Chains. Just a quick overview of what we will go through in the next 15 minutes, a background in motivation, research approach. We'll look at the findings. So in that aspect, we'll have a look at the requirements and relevant blockchain-based architectures. We'll present the emerging architecture that we are proposing for future work as well. A small discussion, and then some concluding remarks, limitations and areas for future work. So for the short food supply chain, we see that there's a growing need for sustainability and consumer quality, motivating this shift from what we see the globalized food system towards food system relocalization, or bringing foods back from a global to a local area. And this in respect builds the need for what we call a short food supply chain. The short food supply chains are aimed to reduce distances. Now, distance isn't always about the physical distance, but also the social distance between actors in the supply chain. So you're trying to reduce the, let's say, the steps within the chain to provide more embedded information to consumers, and therefore traceability is a key aspect of these chains. Literature on quality management in the short food supply chain is limited, and it might not always be considered within these supply chain types. However, there are quite some literature on quality management in the conventional food supply chains, but based on some of the main differences between the chains and maybe sometimes a disregard for quality management in the short chain, there is a need for further work. There are existing blockchain architectures, and they show promise for supply chain quality management, but missing right now is an architecture for the short food supply chain quality management, and that would be facilitated by blockchain technology. So basically, the aim of this research was to conduct an exploratory study to develop a blockchain architecture for short food supply chain quality management based on the key requirements of these supply chains. Yeah. So for this research, we conducted a literature study, a traditional literature study, in comparison to the systematic literature review. And what we were looking for were requirements for short food supply chain quality management, so specific requirements for those, blockchain-based architectures that might be relevant to this study. So for the steps, we did specify the aim, which we talked about in the last slide, and also the search protocol, where we're looking at short food supply chains, food quality, and blockchain architecture. We use the databases IEE, Explore, Scopus, Science Direct, and Emerald Insight. After this, we read the articles and selected those that were relevant and conducted a content analysis on the documents to identify stakeholder requirements, quality requirements, blockchain or technological requirements to support those aspects, and relevant blockchain architectures. So in this diagram, you can see 3 pillars. On the left-hand side of the screen, you'll see the short food supply chain related requirements. So these are the requirements that upstream and downstream stakeholders, for example, producers and consumers within the short food supply chain, are looking for. I will not read them all, but just to give you a quick overview of a few important aspects. Traceability is critical. The consumer wants to understand the origin of the information, the origin of the product and the information behind that. And they also need to support trust, because trust is critical in the short food supply chain. Once a producer loses this, it might have bad consequences for their business performance within these type of chains. In the middle of the diagram, you see the short food supply chain quality related requirements. For example, fairness could be considered a quality related aspect, and the fairness means fair value distribution in that supply chain. Another key aspect of this was the locality and origin, which reflects on the need for traceability. So based on these type of requirements, we propose some technological requirements, and those would be based on, well, blockchain technology. You can see some examples here as well, where we included things like non-repetition to, again, support the elements of quality. Or, for example, the system would need to secure provenance, trust, and credibility of those aspects in the supply chain. We also did reviewed some of the relevant architectures. Two of these here are non-food specific, which are the ones that focus on social sustainability and blockchain-based quality supply chain management. However, the others there, so for example, there was a lot on food traceability. There was one based on trust. Let's see. Also, food safety was involved. However, none of the reviewed architectures were specific to the problem that we're trying to solve. However, they did give a good overview of a potential design for an architecture for short food supply chain quality management. Based on our literature review, we propose this architecture here, and I'll go through it quickly. At the bottom layer, you have the business layer. The business layer mainly consists of different stakeholders within the short food supply chain. At the very bottom of that, you'll see the institutions that are developing these standards. So you can see organizational quality standards, which could, for example, represent the international food standards that are made for large-scale stakeholders usually, for example, large supermarkets. You can see the government quality standards, for example, EU regulations on food quality and safety. And you can see the consumer standards, which also lead towards these participatory quality standards, which are specific to each individual short food supply chain. The middle of that layer, you can see the secondary stakeholders. These are those that are not directly involved within the short food supply chain, but might, for example, provide research or technology, or might be setting policies within the policy, let's say, mechanisms within these short food supply chains. And at the top of that, you can see these short food supply chain, which typically would, in essence, include the producer, the consumer, and potential of one company in between, and of course logistics and transport companies to maybe move the product if the consumer is not going to the start of the chain, or if the producer himself doesn't move downstream. To collect data in the chain from the physical or from the business layer, you have the IoT and communications layer, which uses things like smart objects, sensors, and communication technologies to communicate different elements of that supply chain. So it can, for example, focus on things related to the producer, again, focusing on the origin or the supplier information, what type of supplier they are, where they're based, supply chains, logistics and storage, transport information throughout the supply chain, so through the distribution part, and also information about the customer, retailer, or farm markets where the product is being sold. Above that, you have the blockchain layer, and in this layer, this would be an immutable database. Above that, you have the service and analytics layer. Can be used to provide services for the data and also support the next two layers, which are the trust layer, which provides both mechanisms, so things like reputation, experience, and knowledge in relation to the stakeholders of the chain, and also trust incentives, for example, that can audit, provide rewards and penalties for the supply chain stakeholders. And the final layer is the application layer that users can interact with to, for example, manage quality within the supply chain. So the proposed architecture offers some potential for the short food supply chain quality management, including trust, which is critical to these chains. It's based on the unique stakeholder quality and supporting technical requirements, and some examples of those requirements are listed here. For example, system integration, immutability, credibility, tamper-proof, authenticity, provenance, traceability, non-repudiation, real-time information, reduction of intermediates, and smart contracts. To conclude, we have identified some of the key requirements for short food supply chain quality management supported by blockchain technology. We've proposed a multi-layer architecture to contribute to short food supply chain quality management. We've highlighted some of the key differences between this architecture and existing architectures, and the main difference is the requirements that are specific to the short food supply chain. One of the biggest limitations to this research was the theoretical approach, which leads to the need for future work, and that would be on validation of the model and the architecture through maybe an empirical investigation, and also further requirements allocation and prioritization is required for these types of short food supply chains. On the last slide, I have the reference list that was used for this presentation, and I would like to say thank you for your time, and I am open for any questions.
Thank you very much. You are well within time.